Hello everyone and welcome to Math Bosses. In this video, I'm going to show you two easy methods for solving problems based on tally system that require no form of memorization. But just a quick update, on this channel I upload videos every Thursday based on the GMT plus 1 time zone. So do subscribe if you are interested in more math videos so you never miss any more coming up. Now, before we move on, if you've not watched the video where I explained the concept behind tally system, I would advise you click on the link I believe should be at the top right corner and watch it now to help you understand this one better. Now that you're ready, let's take a look at the first method. This method basically involves subtraction, and that is the subtraction of 5. We keep subtracting 5 until the point where it is not possible to subtract 5 anymore. And what I mean by this is that at that point, the number that we have left is less than 5. For example, we have 2 left. We cannot subtract 5 from 2. So we subtract that number from itself to get our final answer as 0. So where does this lead to? Let's find out. If I choose to change 23 to tally form using this method, the first thing I have to do is subtract 5 from 23. So by doing this, I'm going to get my answer as 18, but it doesn't stop there. The next thing I do is to subtract 5 from 18, which is what I got from the first subtraction. Then I get 13 as my answer. It doesn't end there. The next thing is to subtract 5 from 13. Now that I've subtracted 5 from 13, I'm getting 8. It doesn't stop there. I subtract 5 from 8 to get 3. Now this is where the change comes in. We cannot subtract 5 from 3 because 3 is less than 5. So we subtract 3 from itself to give us 0, as we can see here. Now where does this lead to? In case you did not notice, using this subtraction method has helped us to arrive at a set of numbers, as we can see here, which represents 23 in its tally form. Now we can write each of these values in its tally form to represent 23. Hopefully you remember that 5 is represented by 4 straight vertical lines with 1 line going across it. So we do that for the first 4 5s here. 1, 2, 3, 4 vertical lines with a 5th line going across. 1, 2, 3, 4 vertical lines with a 5th line going across. 1, 2, 3, 4 vertical lines with a 5th line going across. Then the final one, we do the same. Then for 3, represented by 3 straight vertical lines, as we can see here. So this automatically gives us the tally representation of 23. In this video, we will be using the multiplication table to change a number to its tally form, and I'll still use 23 to illustrate this. So I would really like it if at the end of the video you tell me which method you prefer, whether it's the first method or the second method after watching this method. In case you do not understand this table, I'm going to do a quick run through of the concept behind it. Now, when we take the first 5 in white font and multiply by this one in white font, we get 5, and that is how we got this 5 in yellow font. When we take 5 and multiply the 5 in white font and multiply by the 2 in white font, we get 10. That's how we arrived at this 10 here. When we take 5 again in white font and multiply it by 3 in white font, which is here, we get 15. That's also how we arrived here. Then when we continue this way, we'll also get 20. We'll get 25 doing 5 times 5, and we'll get 30 doing 5 times 6. Now how this method actually works is that we have to find out where the number we want to change lies on this table. Since we are changing 23, we know that 23 is a number that falls in between 20 and 25. Now that we know that 23 lies between 20 and 25, we take note of the smaller number, which is 20. Now 20 does not really matter right now. It's the number that is above 20, which on this table, which is 4, that actually matters. Now 4 actually stands for 4 sets of 5s, and this is actually very important in changing to tally form, as you can see here. And we should not forget that 4 sets of 5s is actually equivalent to 20. And this 4 sets of 5s actually means having 5 in 4 places. Like we can see here, we have 5, 5, 5, then 5. And we can represent these 5s in their tally form using the 4 vertical lines with 1 line across, doing this 4 times. Now that we have this established, we know that we are not exactly looking for 20, we are looking for 23. But 4 sets of 5s is for 20. So we subtract 20 from 23. And we get 3. Now 3 is the final value that is missing here, and we represent it by 3 vertical lines. Thank you all for watching this video. If you found the content useful, please don't forget to like, subscribe and share. And also, if you want access to the slides, visit my Instagram account at mathbuses to get access to them. Thank you.